So, as you already know, my name is Vadim Trifonov. I'm leading development of iOS apps in Swedbank. So, today we're going to talk about dependency injection. And before we will proceed, I actually would like to know how many of you write code, because it's so raise hands, please. So, okay, quite a number of hands. So most of you are, in a sense, developers. So my second question then to you is, do you feel that dependency injection is somehow a confusing or misunderstood topic, or some kind of not that clear what this all the fuss is about? Okay, number of hands. So I have good news then for those who raised the hand, that the first part will be devoted to you, and those who haven't raised the hand, the second part is devoted to you, or kind of devoted. So, but let's open up with what the dependency injection, in the basic or everyday terms is. So, one way or good way of approaching it is imagining that you have 5-year-old kids, or maybe you even have actual 5-year-old kids, and whether it would be a good idea for them to sort of figure out for themselves how to cook a meal or how to have a breakfast. Where do they take groceries for the breakfast? Should they scavenge the fridge or hit the shop, mall? Probably not. So a better approach would be actually for them to state their needs. I want to eat. Maybe I want this and that, but someone else who is not 5-year-old will solve this issue for them. So provide the food for them. So this is basically the idea in the higher terms, what the dependency injection is about. So the second question is why pure? Probably the most important here is it's in the topic. So why pure? Well, because dependency injection is not a framework, it's not a library, it's not any kind of a container, it's not any kind of a tool. It's a set of design principles and practices. And why then you might want to use pure dependency injection, not using any kind of a framework or library? There are two reasons. One reason is that maybe your language of choice, like in our iOS case, has no dependency injection libraries or frameworks at all, or they are in their beginnings, cannot be compared with Java, for example. So, and we see that these languages doesn't stop appearing, the new languages, with no established user base, with no decades of community. And these are Swift, Rust, Dart, Go, Solidity. And the second reason is that maybe you don't want this invasive dependency in your code. Maybe it's not a good idea. And if you feel that using this large library for dependency injection sort of pollutes your code, then you're not alone, actually. A famous speaker, Uncle Bob, Robert C. Martin, agrees with you. This is taken from one of his articles, where he explicitly says that he doesn't want his code to be riddled with any kind of add-inject annotations. He wants his modules decoupled and clean. And maybe you want the same thing. And I especially think that the pure dependency injection approach is useful if you're trying to roll something of your own, your home, your pet project, your home project. You don't need complexity there. So let's start with the first part, the fundamentals of dependency injection. What you need, what tools you need for that. So I feel that there are mainly 3 obstacles on the way to pure approach, or on your way to it. So the first one, being the most difficult, is actually to understand the whole concept, the idea. The rest are sort of easier, but an obstacles on their own way. So today I will show you 3 techniques. And the technique structure will be as follows. I will set the context for the problem. Then I will provide you with an insight needed to solve the problem. And I will provide you with active argument what you should be actually doing or using. So let's start with the first technique. And to preface it, another quote for you. Maybe some of you have heard it. It's like, dependency injection is just a 5-cent concept for a $25 idea or something like that. Well, it's definitely true for the first technique, but it's oversimplification. So the context for the first technique is very simple. You have a number of classes, or basically 2 classes. One depends on another. Usually it's some kind of a controller, depends on some kind of a service. So it might look like this. I have a controller, it needs some kind of a service to authenticate. And the question is here, where the service comes from. Whether I instant it myself. Especially if you're a beginner, it's like a very important question. Maybe I take it from some place, maybe ask someone for it. So the insight here is that, or before you even approach the insight, is you have to consider this virtue which is present in software engineering as loose coupling. Something is loosely coupled. So why loose coupling is important? Because it allows us numerous things. First, it's dynamic dispatch. So with dynamic dispatch, you can, in runtime, decide what dependency you will provide or what methods you will execute. There is extensibility. So if you provided good abstractions, you can extend something by just swapping the modules, replacing with something. Then parallel development, again, if you establish some kind of seam abstraction, you can give the development of implementation and development of the particular thing to someone else. Then there is maintainability. Well, basically, loosely coupled code is almost equal to maintainability. It's much easier to disassemble the app and reassemble it again if it's loosely coupled. And the stability. So you can stop everything around some module or unit, and you test it in isolation. So once we've considered that, the insight would be that we don't want to instantiate something ourselves because it would tightly couple us to the thing, and we need someone to provide us with dependency. And this would be an infrastructure of some kind. So my first active argument would be you should use constructor injection for that. And constructor injection is really simple. It looks like this. You probably have seen it multiple times in your life. You just take dependency as an argument. And word of caution, if you're using constructor injection, make sure that your injection constructors are really simple. You don't want to be doing any work there. You just want to take arguments and store them. So let's move to the technique 2. The context of technique 2 is now you have a number of classes. All of them depend on someone. And the question is, who actually initializes them? So I just said that you shouldn't be initializing directly. But someone has to initialize them. How to approach that? Well, basically similar to the previous notion that someone higher on the call stack is responsible for the dependencies, being infrastructure. And we take it to the extremes. And this extreme would be, and my active argument is composition root. So this is the entry point to your application. In Mark Simon words, who wrote actually a terrific book on dependency injection, is like a preferably unique location in your app where you compose an app from separated modules. So in order to understand composition, the idea of composition root better, probably example is needed. So in terms of iOS application, it's really simple. It's your application did finish method. In terms of Android app, it's on complete on create method in your application subclass. For console app, it's simply your main function. And for Windows applications, it's your app XAML. So the simplest composition root would look something like this. Simply a main function where you instantiate everything and set things in motion. OK, this is so far so good and really simple. So one obstacle left. So imagine that now you depend on something which is available only at runtime. So you depend on a runtime value and you cannot pre-instantiate, pre-initialize something. It might look something like this. The session token here is definitely not the thing which is available at compile time. So the insight would be that, again, infrastructure is responsible, but this time infrastructure should sort of promise you the dependency, and given this runtime value, resolve it. And my active argument is that you need to use abstract factory pattern. And word of caution again, if you've read about abstract factory in Wikipedia, then probably it sort of emphasizes not the things which are important for us. It sort of says about like creating a group of different products, multiple products. What's important about abstract factory is that it's abstract, is that double abstraction. It's abstract on its own and it returns us the required abstraction. And abstract factory looks really simple. Some kind of interface, protocol in Swift, which promises us, given the session token, instantiate the client. And the double abstraction comes from itself being an interface and returning an interface. Implementation is as simple as the protocol itself, almost. So if you're lucky ones and your language has functions which are first-class citizens in your language, then you can basically say that it's simply a function which takes something and creates. And you can use it even this way. So let's see in motion. The same example, which we've seen before, but now we've provided beforehand ourselves with client factory. And when the time comes, when token is acquired at runtime, we use the factory to create the client we need and do some work with it. So let's recap. We've learned that we need constructor injection to provide the dependencies. We've learned that it's a good idea to place all your initialization to the composition root, or as much as possible there. And if you're at loss what to do with runtime values, you can use abstract factory. Really simple, free techniques, or even like first principles for your dependency injection needs. And if this is something new to you, and then this is enough. This is enough for you for quite some time. You can do even complex things with that. But for those who feel they know already this and feel that this is not the end, then there is another rather difficult topic to discuss with pure dependency, with any dependency injection, actually. It's scopes. So the idea of scope. So the scope is how long your object or the object state lives. And when something goes out of scope, then it's sort of lost its state for us. And scope relations are also playing an important role. So if something is in the scope of something else, so we can assume that the thing which is in scope will live as long as its parent. So to understand scopes a bit better, let's dive in. Let's take, again, everyday example. So let's imagine that Jack and Jill arrived at the campsite and they need to brush their teeth. So in order to brush their teeth, we need to provide them with a toothpaste. We provide Jill with toothpaste. We provide Jack with toothpaste. They brush their teeth, everything fine so far. So now they again have to brush their teeth. Well, the problem that we again provide them with a toothpaste. They sort of throw it out after each time. You don't keep it anywhere. And it continues. So it works, at least in this case, but it's kind of wasteful. And this is basically the same thing as if you would initialize a new dependency every time you have to resolve it. So another really popular one, and probably the most familiar one, is global or singleton scope. This is basically when you share your state. So with toothpaste, it would be a single toothpaste for the whole state, shared between both Jack and Jill. So the problem here, quite evident, that at some point, the toothpaste probably will run out, and it will be quite unpredictable for both Jack and Jill, because maybe Jack is really wasteful and using a lot of toothpaste. Jill is really like trying to save it. It gets angry. How the toothpaste acts in the sense, or the state of toothpaste is really unpredictable for her, because she's not the sole user. There is a problem here. How can we solve it? We need some kind of a custom scope. We need to create a custom scope. And in this example, the custom scope would be providing with some kind of a buffet campsite where they have a bathroom. And if we would put those toothpaste for their stay in this booth, we've sort of created a scope for the toothpaste. So now both Jack and Jill have separate access to the toothpaste, and it lives as long as it's in this booth and during their stay. So where this idea of custom scopes is important? Interactive applications. So interactive applications are front-end applications, mobile applications, desktop apps, so certain games. And with them, it's really important to figure out your scope hierarchy. So I want to show you an example of our own. So what scopes we figured out are important for us. Let's imagine an app. Well, we start from some kind of a root. This is the entry point. In our case, we have a session scope right after the root. So what's the purpose of the session scope? The session scope monitors some kind of a session state, and depending on whether there is state or not, decides what to do, whether provide you with a login option or transfer you to the logged in state. So if you wonder how this, what this thing actually is in terms of code, you can imagine that this is some kind of a router. And for you, it's enough to know that the router is sole responsibility to keep the sort of all the instances, all the dependencies it needs, and also to navigate to the next scope. So there is function like row to session, and it's somehow able to create it using the factory method, for example, and go to the session scope. So let's continue. As I said, our session checked the session state, determined that there is no session. You end up in logged out state. You present it with some welcome screen, and you have an option to log in. Once you've logged in, the whole part of this tree is thrown away, deattached, and the new one attached. Now you're in logged in scope. So different things are possible when you're logged in scope, and there are different guarantees there. So when you've logged in scope, in our case, bank application, there is a notion of customer. For example, I, as a user, might access the app and have two customers, my own customer and my wife's customer. And given the selected customer or active customer, there is certain functionality available, in this case, balance. So let's take a look what is sort of stored at every scope, examples of things that are retained at every scope. And before we do that, I want to mention that if you're wondering, in terms of mobile apps, that the only nodes in blue color are actually those nodes which show something on the screen. So they present something. And those in white, they are here to sort of create this use case hierarchy and to structure our apps better and to keep lifetimes focused. So let's take a look at things which are present there. So the root might keep a reference to config, depends on the config, how our app is generally configured. Our session keeps a session store. This is where the login writes the credentials or the session token. Once the session token is available, it attaches logged in. And logged in, for example, creates an authorized client. Authorized client is created with a session token, and it's used to actually access the server and query the data for which you need to be authorized. Customer, for example, keeps a customer store, and the balance, which is of importance here, has an account service. So let's highlight those two. There is something important about this too. Account service depends on authorized client, because account service needs to fetch data using authorized client? Well, it's not actually immediately obvious that how to sort of resolve the account service. And we can sort of make two observations here. Why it's difficult? Because authorized client is available only at runtime. We cannot pre-initialize it. And the customer doesn't use it. It doesn't need authorized client because customer is already loaded. So how can we resolve the account service in this situation? Well, there is a lot of a straightforward approach. We can pass authorized client to the customer, but this sort of makes the customer to depend on authorized client. Then the customer, of course, can pass the authorized client to the balance, and the balance can use authorized client to sort of resolve the account service. This solution is quite problematic because now authorized client is a sort of pass-through dependency. It might not seem a big of a problem here, but imagine you have like a really tall tree, and somewhere at the bottom, you need something to access. It's really at the top. So do you want to start passing dependencies down the tree? Probably not. There should be a better way. And I think we have to go back to the drawing board and figure out what we see here. Well, we're discussing the scopes. So first, child scope should be able to access its parent dependencies. In this case, parents should access customer dependencies or somehow inherit them. Logged-in dependencies, session dependencies, root dependencies. Would it be nice to have an access to them without passing them explicitly? And the second, we want fully static compile time guarantee, meaning that if it compiles, then the dependency will be there. It's not any kind of runtime trickery where you might fail. No, we want this guarantee. Can we do that? Let's see. Let's start by introducing a new notion. We'll introduce a component notion. Component name is relevant here. You might have different associations with the name component and forget about them. You can think of it as a dependency provider or dependencies provider. The thing is that it's an abstraction. It's an interface, for example, which stores or declares. It doesn't store. It declares all the dependencies which are needed by the root node or root router. So we just declared what we need. We don't know who will implement it. We don't care about it. We know that the root component also creates a subcomponent or someone who is in his scope. In this case, it's a session component. So session component always depends sort of on the, or is present in the root component scope. By the way, session component doesn't know anything explicitly by the root component, but you can see it by the direction of pointers here. And we can provide those components for every node. So if you're starting to fall asleep, wake up. It's really important because things are getting harder and harder now. So now we need some place to initialize those root components. And this place is not the same module where they are declared in. This is really important. This is not the same module. You can imagine that those root and root component can be declared in one module or library or whatever, whatever way you separate and have boundaries. You need some other place, and this place is near the composition root. And in composition, we will implement the actual providing of dependencies. So if needed, we initialize it. Or if we cannot initialize it, we'll take it from the parent scope. And let's see how we will take it from the parent scope. Well, the thing is that since it's completely separate where we're doing assembly, we can allow ourselves for implementations to know its parent. So implementations is allowed to know its parent component implementation. The important thing here is that abstractions doesn't know anything about that, but the implementations might know, or they know. And this show that they implement the root component. We provide implementations for every component. And let's focus again on these two. We will take a look. If it feels a bit abstract, I want to show you a glimpse of how it might look in the code. So let's take a look at this pair here. So first session and session component. It's a router. You should be familiar already with the router. What's important here is that it uses its own component to create a child component, logged in state, for example, and passes the session token it acquired. Session component is really simple. It only says that it provides a session store for the session router and this possibility to create a make logged in component. And the logged in router on its own does a very similar thing. And its own component looks really similar. It just says that it can create a subcomponent, which is customer. Okay, go back. Now, this is the important part here, of the most interesting. Let's see how the session component and component implementation differ. Remember, they live in separate places. So this is our declaration. We declare that we need some kind of a session store. We don't care from where. And we need possibility to create a subcomponent given a session token. So the implementation living in this white side of the near decomposition route would do the following. It will instantiate the session component, session store implementation, I'm sorry, because it's the first one. There is no one to take it. And when it creates a subcomponent, it will pass, and this is really important, itself to it. Same thing happens here. You see that logged-in component, which we just talked about creating, has as a parent, its parent, which is session component, implementation, which is important. And also does the same for the customer when creating a customer component implementation. It also passes itself as a parent. So if you are not still sort of catched my drift, what's happening here is that we're always depending on our parent on the implementation side. So let's go back to our problem. We still need to initialize account service at the balance component, somewhere take the balance component, at the balance component, from the balance component, somewhere take the account service from. So we will concentrate only on these two, on this pairing. We're almost finishing, but it's the most important part will be revealed here. So pay attention. You already know we set the tone, we're passing the parent, and doing the same thing here as a mark. This is where authorized client is living, which we need. It's in logged-in component. It lives here. We're passing ourselves the parent. Okay, I think what happened is, what shouldn't have happened is we had to run out of battery. So I have to wrap up now. And what you haven't seen was only one slide. What would I do is that finally, in this final balance component, we'll access those parents, because we have the parent, and we'll ask for the parent, for its parent, and going through those parents, we would access the logged-in component and take the authorized client from there. And this would be the whole, I want to call it trick, but it's not a trick. It's a really important, clever technique. So let's try to mitigate this. Maybe it sort of awakened you up a bit. So you have a time to reorganize yourself and breathe. Or maybe not. So let's wrap up. What you've learned today about scopes, 4 important things. First is you need to sort of create your own scope, deep custom scopes. Define your custom scopes. Define your use case hierarchy. Second thing is that you need to define some kind of abstraction which will say which dependencies the scope needs. The third thing is that you would put implementations near your composition root, not where the modules, not where the abstraction is declared, but where the place where you assemble the app. We're lucky. I will torture you a bit more. Don't give up. I want to show you it. Maybe, if it's important, at least for one of you, then it's a success, because it's really good technique. So what will happen now when we receive the parent, which is our customer component, we would traverse the parent tree. We would use our parent, which is customer, ask it for its own parent, which is logged in. And voila, on logged in, we know that there is authorized client. And then we can create account service with that. I will show it here again. The red lines show you the path we reached the authorized client. What's nice about here is that you see that we never sort of said here how we did it. The nitty-gritty part is left here. You can think of it as like, you know, if you will go somewhere, like in your house, underneath the house, there is some wiring and tubes going. This is the wiring and tubes, and this is all the infrastructure part of our app. Nitty-gritty details. And recap. The fourth one, which I haven't mentioned yet, is that if you use this technique, you can traverse your dependency graph upwards. And if, at least for some of you, this sounds familiar, then you're not mistaken, because it's inspired by Dagger, what Dagger does framework, Dagger 2 for Android. It's also compile statically type framework, which is really great. But you can do it in any language. So thank you. Sorry for the bit of disruption. You can clap. Do we have time? We have a bit of time. Do you have any kind of questions, whether it's for the first part or the second part? And we have a microphone here. 2 mics.
Plenty of them.
We have a, yeah.
Yeah, no, okay, thank you. So, maybe I missed something, but could you please elaborate about this white part where you had the implementations of the components? But doesn't it mean that in the code that you shown, there was like tight coupling between the component, between like the parent and child relationship? Like
yes, there is a tight coupling, if that's the question, but only in the implementation details. So the important here is that the component abstractions are not tightly coupled. They only know about their sort of, they can create their child. The abstraction is clean, so this module living here, and customer module, the customer doesn't know anything about that it's being used in the logged-in component. This is really important. The customer component doesn't know that, unless when you start to implement this thing. But this is the composition root, and the composition root, I would argue, should be, if you're thinking about, for example, iOS app, you can think of it as your app, which is basically doing only those implementations and using the rest of the modules, which are, for example, functionality which is placed in our frameworks, to assemble things together. There is no business logic here, absolutely no business logic. It's only instantiating dependencies and retrieving them. That's it. This is sort of like, yeah.
But what would happen if I need to change the order of the like blue things?
What will happen? So at some point, you realize that now you need to have a different hierarchy. So the thing will happen that now, for example, logged in needs to first go not to the customer, but somewhere else. So you would have to rewrite it. You would have to say that logged in now can create another subcomponent, and you would have to correct this part as well. So you would say that customer component now depends on something else coming before the logged in. This is inevitable in a sense, but it's a really a minor pay for what you get, because what we should be caring about is what's happening here in the invisible part, the business logic. Everything which you cannot see lives here. This is where your controllers live, your various interactors and stuff like that, and domain modules. This is only like the dependency part.
Yeah, thank you. And another question, if I might. Can you also elaborate a bit about the composition route in a sense that, do I understand correctly that all of the things that require some dependency injection, they should be initialized in composition route, or there are some boundaries that something should be initialized there and some other things somewhere along the path?
Okay, so the rule of thumb here is that you want to initialize everything that you can actually initialize in the composition route. So in our case, these routers, well, we can initialize at least their factories in the composition route. So we can, in the composition route, we can already see that how our routers will depend. But we cannot initialize components, of course, because components do that at runtime. And if your app is really simple, maybe you don't have runtime value dependencies that much, or you're doing simple thing. If you can initialize everything, you should be initializing everything there. And if you're familiar with the idea of containers, this is where the container thing lives, where you sort of register your dependency, you resolve your dependency, and you release your dependency. So this is like, if you know about what I'm talking about. So answering to your kind of question, or wrapping up your question, you initialize everything which you can initialize. The rest will be initialized at runtime.
Thank you.
Okay, it seems you're either shy or there are no more questions. Let's then continue.
Thank you for the presentation. I have a question or thinking, isn't it too hard to, how to say, always follow up the parent and then the parents and so on, maybe to, at some extent make some kind of dependency cloud, like it's spreading, or how it's in your banking app, like how the whole scope looks like, because I'm thinking that it's quite complex, right?
It was part of our scope, and if you're thinking about the cloud, then I see what's your idea is like. I want just to take it from somewhere and don't care how what the dependency graph actually is. So just provide it me. It sort of feels like maybe, to me at least, as like a service locator pattern. But the problem with those patterns, the cloud patterns, is that there is no compiled safety there. So the idea usually with cloud is that someone will put something there at runtime, and you will hopefully be able to resolve it. This is the bad idea from the static guarantee viewpoint. And moreover, if you're talking about the cloud, then we don't have any kind of scope. Probably it's some kind of a shared thing then. You either resolved a new dependency or you provided the same thing which everyone else uses. The idea of scope was to sort of have deep hierarchy, so that only in this scope I have this access to those things. Or only logged in scope and I can access authorized client. I shouldn't hope to access the authorized client and in any place in our app. If I would do that, then I would end up with this common problem which almost everyone have had when we initially started to build apps, is that this sort of authorized client starts to check whether it has session token or not. If it hasn't, then it's some kind of a big error, like you're in invalid state or something like that. We won't avoid that by cleverly creating the hierarchy. And the more complex your app is, the more important it is.
Thank you for the presentation. But if I see the code, it's like parent dot parent dot parent. Like what do you think about the code readability in that sense? I think it's very hard to understand to track the parents. Like if I have around 5 or 10 parents, then reading the code is more difficult, I feel.
So, as I understood the question, the concern here is that once we start to have 25 parents, then it might become a bit unwieldy or difficult. Well, we can sort of have a backwards argument. How would else you would approach this complexity? Would you use a shared state? So if you have so many actors and using the shared state, you will end up even with a bigger mess. So I don't see the 25 parents, even 25 parents is a problem. We haven't exceeded this number of being so tall. Usually it's somewhere around like maybe 10 or something like that. Because you also should remember that you're not only going downwards, but also in different directions. So things that are possible in this scope, not possible in this. So you may be switching between scopes. Or it's a tree. It's also broad, not only tall. So
thank you.
We are running out of time. So thank you for your questions. I will be hanging there. If you really want to see some kind of code, I have a bit of code to show you the concept, and I will answer any other questions.